Alright, this video we're going to do determinants and Cramer's rule. These are two different things. You're going to use Cramer's rule to solve this and solve this. It's just another way to solve systems of equations. Notice that this one, I'm essentially going to tell you guys a hint right here. Notice that this one's missing the y, so that means that you need to put a plus 0y in between right here, in between your x and your z. So don't forget that plus 0y. I'm going to collect this when you come to class, so be sure that you have this. I want you to find the determinant here, the determinant here. I need you to show me your work, so I know a lot of you guys are going to be able to do that in your head. I want you to actually write out the work so that I see it. Then I want you to use Cramer's rule for this one and for this one to solve them out. Okay? So I'm going to go through the process showing you guys what's going on here. A determinant, what that means is, what you're doing is you're finding the difference of the products of the diagonals. So what I mean by that is I'm going to put letters in here, A, B, C, and D. We're going to do the product of A times D, and then we're going to subtract the product of C times B, and that's the determinant, and I'm going to indicate that with a small d. So that's what I mean by determinant. Now when you're multiplying down and to the right, it's going to be positive, meaning that you're adding that value. When you're multiplying up and to the left, or sorry, up and to the right, it's going to be negative, meaning that you're subtracting away that value. So notice that I used positive A times D, and then I subtracted C times B, and it's always going to be like that. So I'm going to do a couple of examples. If I was finding the determinant of this, I'm going to multiply this way, and then I'm going to subtract away the products of this way. 4 times 1 is 4, 3 times 2 is 6, so this is going to be negative 2. And that's all that we're finding right there, okay? Now when I say that it's positive, I didn't mean that you automatically make it positive. What I mean is you're adding it. So I'm going to add together negative 1 times 4, which is just multiplying them, and then I'm going to subtract away whatever's coming here. So negative 1 times 4 is negative 4. 2 times 7 is 14. So this gives me negative 18. Hopefully that makes sense, because if it doesn't, then it's going to be really hard to do the next part, okay? So this guy named Cramer, he came up with a rule on how to solve systems of equations with two variables. Actually, any systems of equations, but we're going to do two variables. So if I have a system of equations that looks like this, ax plus by equals c, and then in the other one I'm going to do dx plus ey equals f. I can rewrite this into a matrix equation by saying a, b, d, e. These are just the numbers in front of my variables. And then I'm going to multiply that times xy, and that's going to equal cf. That's just setting it up, okay? Now what I want to do here is I actually want to use these columns the same in Cramer's rule as they show up here. So the columns kind of go together, and what I mean by that is this column is going to go together, this column is going to go together, and this column is going to go together. Okay? So what's happening here? Well, Cramer's rule says that we can find the solution for x by doing, these are my x's. What I'm trying to solve for is going to be replaced with the solution. So these are going to get moved out, and this is going to come in. So it's going to be cf. The y's stay the same, be. And this is divided by the determinant of the original matrix. Y is going to equal, I'm trying to solve for y, so the x's are going to stay the same, so AD is going to still be there. The y's are going to be moved, and it's going to be CF, and that's going to be over the determinant. Okay, so I'm going to do an example of this right now. If they give me an equation that says 2x plus 4y equals 10, 3x minus 2y equals -6. Hopefully this gives me whole number answers, but we'll see. So first thing I'm going to do is I'm going to set up my matrix, which is going to be 2, 3, 4, -2. I need to find the determinant of this, which is going to be 2 times -2 minus 3 times 4. 2 times -2 is -4. 3 times 4 is 12. So this gives me -16. So I'm going to say x equals this new matrix that I'm going to make over -16. Y equals the new matrix that I'm going to make over -16. Now remember, in your x, you're replacing your x's, you're replacing this column with the solution column. So it's going to be 10, -6. The y's stay the same, 4, -2. When you're finding the y's, you're going to replace the y's. So the x's stay the same, 2, 3. And then we replace the y's with the solution column. Now obviously this isn't the answer. What we need to do now is we need to find the determinant of this matrix right here. So we're going to do 10 times -2 minus -6 times 4. 10 times -2 is -20. A minus a negative is plus. 6 times 4 is 24. So that gives me 4. So x is going to equal 4 over -16, which is -1/4. I need to do the same thing, find the determinant here. So I'm going to say 2 times -6 minus 3 times 10. 2 times -6 is -12. 3 times 10 is 30. This is going to be -42 over -16, which is going to give me a fraction, right? Negative over negative is positive. It's going to be 21 over 8. And I can't simplify it any further. So my solution to this original deal here was -1/4, 21 over 8. If you would have solved it using elimination or substitution, you would have came up with the same answer. So those are the kind of simple ones. Now let's do a more complex